Swayam Prabha. Digital India. Educated India.
Welcome friends, in our first two sessions of this particular course on operations analytics, we understood that what is the changing landscape of operations management. We understood that the role of analytics is to improve the value addition process of operations management. We discussed that how operation management is also going to become a strategic source for organizations. It is no longer a reactive or neutral activity, but it is positively contributing in achieving the objectives of the organization. We also discussed large number of applications ranging from PPC, forecasting, inventory management, quality management, scheduling problems using the analytics. That how analytics can be helpful in all those places where you have generation of data, wherever you have uncertainty. So, you please understand one thing, which is you see underlying across the domains, that wherever you have more uncertainty, data is going to help you in making better decisions. Those areas where uncertainty is less, things are more or less are on usual path, more or less you can say stable path. Using too much of data, spending too much of energy on analysis may not be advisable from operations management point of view. So, you for your organization, you should be very clear that what are the areas where amount of uncertainty is very high, and therefore, more data analytics will help you in handling the challenges coming because of this element of uncertainty. As we discussed in our very first session, that there can be three levels of business analytics, starting with descriptive analytics, then predictive analytics, and then ultimately prescriptive analytics, where we are looking for what can be the best decision in a particular scenario. So, in this particular session, we are going to focus on descriptive analytics, where we are trying to understand what has happened and why it has happened. So, it is more about using your past data in a very systematic manner, transparent and fair manner, so that that data arrangement itself shows you various interesting insights. We just concluded a very popular tournament of our country, that is IPL, and now World Cup is starting, World Cup for T20 is starting. Now, in IPL, in World Cup, large number of analysts are available and they are predicting the success, failure of different types of players, different teams. Now, in this World Cup, there are some new teams. For example, Canada, USA, etc. These are some new teams which are playing this World Cup for the first time. Now, we do not have much data about them. So, it is very difficult to give any kind of analytical suggestions to these teams. And on the basis of no data available, other teams will also not be able to understand their strengths and weaknesses. While the teams which are already playing the game of cricket for very long periods like India, Pakistan, England, South Africa, Australia, etc., huge amount of data for every player is available, huge amount of data as team is also available. So, all that data can be used for descriptive analytics. So, descriptive analytics is basically based on the availability of huge amount of data, historic data, and how are you arranging that historic data for getting some interesting insights. That is what we are going to discuss in this particular session. So, we will be talking of what is basically the descriptive analytics, some use cases of descriptive analytics, and then whenever a set of data is available to you, these are the two very important things which are going to define the characteristic of that data. One is the measure of central tendency. There can be different types of measures of central tendency. We will be talking of them in the coming slides. The measures of variation, how much inconsistency is there in that data. A cricket player may hit a century also in one match, and in another match the same player may be out on a duck. There is another player who is consistently scoring, let us say, 40 runs in every match. So, a player who is scoring century and a duck, there is a huge variation, 0 to 100. And on the other hand, there is a player who is consistently scoring only 40 runs in every match to match, though it is a hypothetical example, but for our understanding purpose you can consider that you have no variation in this particular case. So, the central tendency and the measure of variation, these are important characteristics of any data. If you want to specify the characteristic of a data set, you need these two measures. Those who have done any course on stats or any other courses related to analytics, they know that many a time we used to say that what is the mean demand and what is the sigma of the demand. So, mean is basically central tendency and sigma is variation. So, that is how you are defining the data. We will be talking of some interesting central tendency and variation measures, and then we will give you some hands on experience of getting the descriptive analytics outcome using a very simple tool of Microsoft Excel. So, let us first understand what is descriptive analytics, which involves the use of current and your historical means past data to identify the trend in the data and the relationship in the data, that how data is increasing, decreasing, remaining static over a period of time. So, it provides a straightforward view of what has happened without delving deeper into the underlying causes. So, what is available to us in the form of some data, we just see the face value of the data. Why these numbers are like this? That probably is not the interest of descriptive analytics. We just see the numbers. For example, this is summer season and every day mercury is rising 42, 43, 45 plus. So, I can calculate that what is the average temperature of the month of June in Roorkee. So, this is just one example of descriptive analytics. The other person will also be interested that why this temperature is rising so much. What are the reasons? That is not the scope of descriptive analytics at the moment. So, as I already mentioned that simple softwares like Excel etc. are used for doing your descriptive analytics. We will show in the class that how we can use the Excel's power for getting different types of descriptive analytics answers. It is actually a foundation for various other serious type of data analytics approaches like predictive and prescriptive data analytics is only based on the data provided by the descriptive. So, you can say that for your predictive and prescriptive analytics, descriptive analytics is input for the higher order analytical tools. Some of the popular use cases of descriptive analytics, like use case that is in the field of traffic management. So, organizations they track engagement through social media analytics or web traffic. So, how on different intersections, for example, what type of number of two-wheelers, three-wheelers, four-wheelers are coming in the morning time, afternoon time, evening time, night time, so that you can create different types of engagement reports for different crossings. That itself is a very interesting use case of descriptive analytics. So, your daily data is generated, and nowadays all that data can easily be collated and huge amount of reports can be generated about your traffic flows from different type of intersections in your city. Sales and revenue analytics, that is another very interesting area, and I think many organizations are using descriptive analytics for this very purpose, very common, because organizations are always interested to know that what is the peak sales period throughout the year. Let us say from January to December. If I talk in India, there may be many peak periods. For example, one peak period may come around April and May, where you have a wedding season. So, demand may go slightly up. Another peak period may come during Diwali time, demand can go up. Another peak period may come in December, which may flow up to January, again it is a wedding season. Let us say throughout the year, these three are the important periods of improving your demand. Now, out of these three seasons, which season gives you highest peak in your sales performance? These kind of simple analysis, and accordingly you will understand that we can do our inventory management also. Earlier, the demand for school dresses, demand for school uniforms were very high in the last week of, let us say, June, first week of July. But now with the data analytics, we are able to understand that this period is shifting to, let us say, first week of May, last week of April, because now the entire season or cycle of school education is changing, and therefore, the peak period which used to be July and June, now that peak period is April and May. So, these kind of analysis are easily possible and very important for all the shopkeepers, all the businesses. Customer segmentation related descriptive analytics, that how many different segments you are having, and which segment is giving you how much of order, which is your most priority segment. In fact, this segmentation is also done by not only business houses, but the political parties also, that who is my target voter and how many vote we can expect from my target voter segments. So, this is quite a bit used by organizations. Inventory management is another very popular case which I just mentioned with reference to our sales and revenue analytics, that help you in planning your inventory, that whenever your peak period is coming, you should have your inventory ready before that. Another important thing in inventory, that in year 1, year 2, year 3, what is your average work in process? What is your average work in process? Average inventory work in process means average inventory in your pipeline. So, when I am using the descriptive analytics, I will give these inputs to various improvement exercises, and with that improvement exercise, I will always look that year on year my WIP should reduce, so that my cost which is involved, my capital which is involved in that work in process can be minimized. It will give me more, you can say, agility. It will help me to achieve the objectives of lean manufacturing. It will help me in improving my efficiency also. So, that is inventory management kind of things where descriptive analytics will be used. A lot of use of descriptive analytics which will be there, but presently it is slightly out of scope for our discussion in this operation management class, that is financial reporting. Organizations use financial reporting data, and in the financial reporting also they generate balance sheets, they generate their income expenditure, cash flow expenditure, profit and loss statements, etc. And all these statements are actually the summarization of huge amount of data point of one particular financial year, one particular quarter of the financial year, etc. So, summarization, actually descriptive analytics is summarization of your so many data points. You have thousands of data points in a particular period. Now, if those thousands of data points are scattered, you will not be able to make any decision. So, now summarization of those large number of data points into a meaningful you can say outcome, that is descriptive analytics. So, the entire financial reporting, whether your balance sheet, whether your income statement, whether your profits and loss statements, whether it is your cash flow statements, all these are again the summarization of those data points, so that you have a meaningful meaning of that entire data. So, these are all simple use cases of descriptive analytics. The list is not exhaustive, but it gives you fair amount of idea that in how many different ways descriptive analytics are used, can be used in the organization. Now, coming to two important type of characteristics which define your data. In that, as I mentioned in the beginning of this session, one is central tendency and another is variations. Now, when we talk of central tendency, because to know more about these things, you can join or study any basic textbook of statistics. So, that will give you more clarity, but for our purpose for this particular course, I am giving you a very brief introduction of a measure of central tendency. Now, when you have, let us say, data of this type, that this is demand data for January, February, March, April and up to December. So, you may have the demand data of 1000, 900, 950, 1100 and so on up to let us say 1400. That is how the demand data for a particular product for every month is given to us. Now, this individual data will not give you any significant information. This is important because all our analytics will be based on this raw data only. Now, when we have this raw data with us, you can first thing you need to see these three very basic measures of central tendency. Very basic measures of central tendency. First is arithmetic mean, which is simply you have to do sigma of all these data points. Xi, this is Xi, this means X January. Here I means period. So, I will be January, I will be February, I will be December also. So, you have X January to X December. So, you have total I equals to 1 to 12, or you can say I equals to January to December. Here I is January and n is less number. You will do the sigma of all these different periods demand divided by 12, that is arithmetic mean. That is also known as, in our simple language, you can compare it equal to average. However, average many a time may not be a very good measure of central tendency. There are certain limitations of average, because average is a very sensitive measure of central tendency which is affected by outliers. For example, here in this data you see that all the periods are around 1950, increasing slowly and going up to 1400. For example, now you consider a particular period, let us say October, for which the demand is just 100. This is known as outlier, which is completely away from the other data points. Other data points are ranging 900 to 1400, but there is a period for which the demand is just 100. Now, this 100 demand of a particular period is going to affect significantly this average calculation, arithmetic calculation. Similarly, now if I consider that this October's demand is not 100, it is 10,000. This is also outlier. Other periods demand is around 1000, 1200, but one period is 10,000. Now, if I take that data of 100 or 10,000, these are going to significantly impact my arithmetic mean calculation. So, therefore, I say that it is a very simple way of knowing the central tendency data of your data points, but not very good, because this is very significantly or very, you can say, sensitive to the outliers. Sometime if your data is in negative and positive, then in that case negatives and positives will cancel out. For example, there is a place you just think hypothetically, night temperature of that place is minus let us say 10 degree, and day temperature is plus 40 degree peak temperature. So, you will say that average temperature of this place is plus 40 minus 10 divided by 2. So, this becomes 30 by 2, that is around 15 degree. So, you will say that this is a very comfortable place, 15 degree temperature is the average temperature of the city, but you see that temperature is going as low as up to minus 10, which is severe cold, and day temperature is going as high as 40 degree, which is severe hot. So, neither it is hot nor it is cold, you are saying city is very comfortable, it is a 15 degree centigrade temperature. So, many a time this arithmetic mean is a very misleading kind of a simplification of your data points. So, to overcome these issues, we have two more measures of central tendency, that is median and mode. Now, here with the help of this particular simple diagram, we are trying to explain you what is median. Median is exactly the mid value of your data points. Here it is important that you have to arrange your data in a particular order, whether ascending or descending, it is up to you, but you have to arrange your data in a particular order, and then you will be able to get the midpoint of your data. So, like in this particular case, here these are the 4 data points and these are also 4 data points, and this is the medium value, mid value of entire data point, middle point. Mode is another, which is the data point which is most frequent in your data set. So, like in the same example where we have 9 data points, out of that we saw that this particular data point is repeated again and again 3 times, and therefore, this becomes my mode. So, these are some kind of improvement over arithmetic mean. And then one more central tendency measure is possible, that is geometric mean, and this geometric mean is where we are taking geometric mean of all the data points. So, if you have let us say 3 data points, so it will be x1 multiplied by x2 multiplied by x3, and then you will take cube root, of these 3 data points. So, that is another useful way of knowing the, this is generally used when let us say we are talking of growth rate over a particular period from 2014 to 2024, we have annual growth rate of our country. What is the average growth rate for this entire period? Geometric mean will be used for that calculation. Then we have measures of variations. So, not only central tendency, but variation, that what is the spread of your data, that is also very important, and there are different types of measures of variation also. One is range. So, like you have data point from 1000, 1100, 900, 950, 3000. Now, range will be simply the lowest minus highest. So, 3000 is the highest minus 900, that is the range, that and you have to again arrange the data in the ascending or descending order. So, highest and lowest, the difference of these two data points, that is the range. Another very commonly used measure of variation is variance, where you will use some kind of formula that you will calculate the average and how the data is moving away from that particular central point, that is the variance. Variance and standard deviation are more or less similar way of calculation. The only purpose of variance and standard deviation to have two separate measures of variation for their use in our mathematical calculations. We cannot add one standard deviation to another standard deviation. So, if it is a variance, this is standard deviation. So, actually variance is a square of standard deviation. So, if you calculate the variance, the standard deviation is automatically calculated. And then another thing is coefficient of variation. So, when you see that in our previous slide we talk of arithmetic mean. So, the relationship of standard deviation and arithmetic mean, that is coefficient of variation, because in some cases just by standard deviation you will not be able to understand the variation in its totality. So, you need to see that what is the bigger size of the sample. So, out of that sample, let us say if there is a case where the average value is 500 and another case is average value is 50. Now, in average case of 50 versus 500, here for example, I can still bear the variation of 5, but if I say variation of 5 in this particular case with respect to 50, this variation is very high, and this variation of 5 in case of 500 is not so significant variation. So, therefore, just by having the standard deviation number you will not be able to understand the correct picture of variation. So, therefore, coefficient of variation will help you in getting more realistic picture of your variation. Like in this particular example, you see that different types of cases are there. This is the mean value, average, and based on how data is distributed, this is one case, this is another case. you see that data is distributed according to their spread. So, when you have almost a flat curve number 1, here you see the variation is high, while in the second case where you see a peak type of situation, then you can say that variation is less in that particular case. So, therefore, both these things are required to get a true representation of your data, mean as well as your variation. Excel is a very simple way for getting the information about all these calculations. Let me just take you quickly for Excel application, and with that application we will be able to see that how we can do all these kind of descriptive analytics in a very fast manner. So, if I can go to Excel sheet, so here we have some data in front of you which I have already punched. You may use the same data or you may use a different set of data. Like you see that in column A, from row number 2 to row number 14, we have kept some random data, arbitrary data. Now, the simplest kind of analytics which we can do, I am going to put every kind of analytics in column number D. So, first I am looking to calculate the mean. So, if I write the formula, so I hope we all know how to write the formula. So, I have to write simply average, and I will select the range for all these. So, this is the descriptive analytics related to average. Let me write this is average. Then we can calculate here median. So, without actually I told you that we have to arrange the data in ascending descending order, but all these functions are inbuilt in Excel. So, I need not to do that. Internally Excel does all these things, and again you see that even if I do it manually, I will get the median like this 2,22,000. So, this is the median. Now, another simple is mode. So, we can use the same way formula for mode, and let us see what is coming. So, this is the mode value, that is 1 lakh. So, all these are the simple descriptive analytics which we are getting. If you can see this data, their mode is 1 lakh, which is appearing 2 times in this table. Then let us go for a few more descriptive analytics. Now, we are going for range. Here we are going to calculate range. So, range we will calculate the highest minus lowest. Max minus minimum of these. So, this is the range of this data, that is 1 lakh 19 lakh 62,000, that is the type of range you have. Now, directly we will go for standard deviation of this data. So, this is the standard deviation for this data. Now, we are doing all these calculations manually for your purpose, that whatever you can say descriptive analytics you want, you should be able to calculate it. But there is a possibility that you can use all descriptive analytics in one single go if we use a simple tool of Excel that is available in Excel solver. So, let me highlight the use of that. If you go to data tab in the top of this Excel sheet, and then you go to data solver, and in the solver, when you invoke the solver data analysis, sorry, that in that analysis tool pack, there is a option for descriptive statistics, and when you click this descriptive statistics, you need to put the input range. Now, the data which we want to analyze is available from A2 to A14. So, that is my input range by the column, and now I want to put my answer, let us say somewhere in G7. So, G7 I will like to put my answer, and you will see that all the interesting outcome like mean, you can see that this is the same mean which we have just calculated. There may be some slightly rounding of issues, but it is more or less same. The median we calculated. So, rather doing every calculation separately, putting formula for everything, you can use these things like this. Standard deviation may have some difference, and then range is there, minimum, maximum, and all these things are available in this simple directly. Now, it is up to you that out of this entire descriptive statistics, which type of stats is to be used in your case. So, this is a standard template, but you can use this for some kind of more customized let us say findings. For example, I just want to count how many house prices are more than 1 lakh. So, there is a function in the Excel that is count if. So, let us see the count if function, count if, and here you need to give the range again, and then you have to set the criteria. Our criteria right now is more than 1 lakh. So, that is the criteria we are putting, and we will see that how many house prices are more than 1 lakh. So, out of 13 house prices, 9 are more than 1 lakh, only 4 are less than 1 lakh. So, you can play in this way, you can find more and more useful stats which may be required for your purpose. For example, right now as I said, election time is going on, results are going to come, then party may be interested, one party which is winning, that okay, how many are those seats where our winning margin is more than 2 lakh, how many seats where our winning margin is more than 3 lakhs, how many seats which we lost, our margin of loss was let us say less than 10,000, because then the party may make a strategy that okay, where the margin of winning the opposition is less than 10,000, we can work hard and we may take the seats in the subsequent elections. So, just by using appropriate descriptive analytics, we may find various useful information. So, with this we come to end of this particular session, and I request that you can use more such insights on your own using the Excel, and you will see that how interesting it is to get different types of insights from the available data. Thank you very much.